In this lecture, we'll study about second type of proof that is called as indirect proof. Okay, so instead of proving the given proposition directly, we establish the proof of the proposition through proving a proposition which is equivalent to the given proposition. Okay, so we have given a proposition, suppose P is a proposition. So instead of proving this proposition P directly, we try to prove a proposition Q which is equivalent to P. Okay, so when we prove Q, then indirectly we are proving P. So that is called as indirect proof. Okay, so there are three types of indirect proof, and the first one is called as proof by contradiction. Here we start with the assumption that the given statement is false. Okay, so here we start with the assumption that the given statement is false. By rules of logic, we arrive at a conclusion contradicting the assumption, and hence it is inferred that the assumption is wrong, and hence the given statement is true. Okay, so in proof by contradiction, we start with an assumption that a given statement is false. Okay, then by rules of logic, we arrive at a conclusion that is contradicting the assumption. Okay, and hence it is inferred that the assumption is wrong, and hence the given statement is true. So to clearly understand this proof by contradiction, let us take an example here. So in this example, so that root 2 is irrational number. Okay, so let's suppose it is false. Root is irrational number is false. Then root 2 is irrational number. Okay, so assume that root 2 is a rational number. Okay, now we have to find a contradicting statement, okay, from this statement, and hence this statement will be, this assumption will be wrong and the original statement will be true. Okay, so assume that root 2 is rational number, which implies root 2 can be written as a divided by b in the form of pq, or a divided by b, where b not equal to 0. Okay, where b not equal to 0 and a and b have no common factor. Okay, so b not equal to 0 and a and b have no common factor. Okay, so it can be written as which implies a is equal to root 2b. Okay, so squaring both sides, a square is equal to 2b square. Okay, so this is squaring both sides. Okay, we know that if a is a even number, okay, then a square is also an even number, and it can be shown here. A square is written in the form of 2 into something. Okay, so which implies a is, or you may write which implies a square is even number, which implies a is even number. Okay, so now since a is an even number, so you can write which implies a is equal to 2 into t. Okay, for some integer t. Okay, so now here a is equal to 2t, so put the value of a is equal to 2t here. Okay, so we'll get, this implies we get a square is nothing but 2t whole square is equal to, so this is equal to 2b square. Okay, so this is equal to 2b square, which implies we have 4t square is equal to 2b square. Okay, so this implies b square is equal to 2t square, which implies b square is even, which implies b is even. Okay, so what we assumed that b not equal to 0 and a and b have no common factor, but we arrive at a situation where a and b both have a common factor, because a is also an even number, b is also an even number. Okay, so which implies there is a common factor between a and b. Which implies there is a contradiction. There is a contradiction, which implies original statement is true. Okay, so which means original statement is true. Okay, so what was the original statement? Original statement was proof 2 is a irrational number. Okay, so in this way you can prove it. So come to the example, another example. So this is nothing but example 2. So that if 3n plus 2 is an odd integer, then n is odd. Okay, so let us assume that let's suppose this one is false. Okay, so let's assume that if 3n plus 2 is an odd, okay, so just write down like this: 3n plus 2 is an odd integer and n is even integer. So this is our assumption. Okay, since n is even integer, okay, we have n is equal to 2t for some t belongs to integer. Okay, so now put the value of n is equal to 2t here. Okay, so 3n plus 2 is equal to 3 into 2t plus 2, which can be written as 2 into 3t plus 1. Okay, so which implies 3n plus 2 is even number. Okay, so this was the assumption, but there is a contradiction. 3n plus 2 is an odd integer, but what we are getting here, 3n plus 2 is an even integer. So there is, which implies there is a contradiction. Okay, hence original statement is true. Okay, so this one is proved. Okay, so in this way you can prove by contradiction. So now comes the second type of indirect proof, that is called as proof by using contrapositive statement of the given statement. Okay, so contrapositive statement is nothing but p. If I have a p conditional, q, okay, then this is equivalent to negation q conditional negation p. So this is the contrapositive statement of p conditional q. Okay, so instead of proving p conditional q, we prove its equivalent, that is negation q conditional negation p. The contrapositive of a conditional can be formed by interchanging the conclusion and hypothesis and negating both. Okay, so we can just interchange this one and give a negation symbol, then you can have a contrapositive statement of a given statement. So come to an example here. Prove that the function f r to r defined by fx is equal to 2x plus 5 is 1 1. Okay, so now we have to prove this one by using contrapositive statement. Okay, so here we have to prove fx is 1 1. Okay, so p is nothing but if fx1 is equal to fx2. Okay, so it can be written as, hence fx is in a 1 1 function, so by the definition, if fx1 is equal to fx2, then x1 is equal to x2. Okay, so by the definition of 1 1 function. Okay, so here, so this one, the first element is p, and then next x1 is equal to x2 is q. Okay, so the contrapositive of above statement is x1 not equal to x2. That's a negation of this. Then if x1 not equal to x2, then fx1 not equal to fx2. Now you have to prove this one. If you prove this one, then you are proving this one, that is fx is a 1 1 function. Okay, so we start with x1 not equal to x2. Okay, which implies 2x1 not equal to 2x2. Okay, multiply to both sides, which implies 2x1 plus 5 not equal to 2x2 plus 5, add 5 both sides. Okay, which implies 2x1 plus 5 is nothing but fx1 not equal to 2x2 plus 5 is nothing but fx2. Okay, so we start from x1 not equal to x2 and we arrived at fx1 not equal to fx2 by contrapositive. Okay, we prove the original statement. Okay, so in this way you can prove any statement by using contrapositive statement of the original statement. Come to another example. Prove that if 3n plus 2 is odd integer, then n is odd. Okay, so the contrapositive of above statement is n is even. Okay, if n is even, there is a negation of n is odd, and then 3n plus 2 is even. If n is even, then 3n plus 2 is even. Okay, that is the contrapositive of the above statement. Okay, start with n is even, which implies n is equal to 2t for some t belongs to integer z, which implies now 3n plus 2 can be written as 3n plus 2 is equal to, put the value of n here, so we get 3 into 2t plus 2 is equal to 2 into 3t plus 1. This implies 3n plus 2 is even. Okay, so from here n is even, we got 3n plus 2 is even. Okay, by contrapositive, the original statement is true. Okay, so hence proved.